So this video, I will start you off with what we in our family call a tale of woe. So yesterday I came in and recorded a 9.2 video that you already watched, and you actually didn't ever watch the one I recorded yesterday. That's why it's a tale of woe. I recorded a 9.2 video, recorded a 9.3 video in two parts because this will not fit in 20 minutes. Recorded a 9.4 video, got those all done. Tried to get a copy from my computer to my computer from the SD card. Spent about, half an hour fussing around with that, and the SD card was giving me all these weird messages and wouldn't read. And eventually it said, there's nothing on your SD card and this needs to be formatted, which means you erase everything on the card and lose it, start from nothing. I tried it in like 10 different devices. Every device said this card needs formatted, and I gave up, formatted the card, started over, and I'm back at it today. So you're watching 9.3. If you are wondering if I'm wearing the same clothes for like 3 days in a row, I am not. This will be one triple lesson recording to replace our triple lesson Tale of Woe recording session from yesterday. If you're not watching this in 2020 and this video gets used some other year, you have no idea what in the world I'm even talking about, but this is coronavirus central right now. 9.3 has two companion papers that could help you. There's a fill-in-the-blank paper with 9.3 vocabulary kind of things and some stuff at the bottom that's on the board. And then there's a graph paper that will cause this to go into a session 2 of recording, and that'll get recorded and pieced together by my director at a later point in our day today. So the 9.3 notes, if you were here, I'd ask you to do what I'm going to ask you to do anyway, which will be in a second. Pause the video and see if you can fill in the top 9 are all ideas from yesterday. If you thoroughly understood yesterday, you'll be able to do the top 9. If that's a little bit of a blank, I'll repeat those answers in a minute, and when I do the 1 to 9 answers, I'll just keep rolling, and that'll morph us into today's 9.3 notes, and then we'll feed to the board in a minute. So it'll be now time to pause, and we're back. So transformations for number 1 are changes to graphs. Not making this paper, but yesterday we did translations, which meant they were just moving. Today, when we transition around number 10, nothing's moving anymore. Everything's going to get stretched. A whole different idea today. 2 is U's. 3 is V's. Squares make U's. Absolute value make V's. 4 is the vertex. The vertex is the bottom of the U or V. 5 would be up 1 in both directions. 6 for absolute values is up 2 in both directions, but up 4 for squares. 7 was adding because we moved, translations. 8 was up for positive is one pairing, down for negative is the other pairing. Key thing on 8, we're not in the parentheses or bars. Not in parentheses or bars is up or down. 9 in the parentheses or bars is going to go right for negatives, left for positives. Opposite effect of what we were thinking we were doing. None of that's going to appear on the board today. None of that has to do with tonight's homework. That's just a recap of yesterday. 9.4, we're going to have to put both days together. 9.2 is moving, 9.3 is stretching, 9.4 is, hey, let's do a lot of stuff. Today, all of the equations for number 10 are changed by multiplication. If you look at the bottom, you can see a whole lot of multiplication going on from 1 to 16. Behind me on the board, you see some multiplication. No adding, subtracting, no moving. All multiplication for stretching. And I just gave away the next answer a few times as I talked. Stretch. So 10 is multiplying and stretch. 11, if there's a number not in the parentheses or bars, we're going to make the graph taller. For example, a 2 multiplying would make the graph 2 times taller. A half would make the graph half as tall. So I'm going to turn around here and look for some of those. Okay, so this is the kind of number I'm talking about. This is the multiply number not in the bars. That is going to make me get 3 times taller with my graph when the time comes to graph it. If I take a step to the right, this half is going to be half as tall. And if I take a step down here, this is another 2 times as tall thing because of that too. I'm marking the problems now in the column from 1 to 8. So if you didn't realize that, because I didn't say that, that'd be natural. Pause the video or rewind the video and fill in those couple answers down there. That number 1 was 3 times as tall. Number 3 is half as tall. And number 4 was 2 times as tall, among other things. But these are appearing on the board. When I write on the board, I'm filling in 1 to 8 with you. 12, if the numbers are in parentheses or bars, it's not taller, it's going to be wider. So behind me I have some wideness kind of questions. To my left, your right. But like yesterday, we have the opposite effect happening. Yesterday the adding didn't send us right like you feel like it should, it went left. Okay, so today it's again opposite, but in a reciprocal, flipping kind of way. A 2 in the problem is going to make the graph half as wide. Because 2 is like it's over 1. You flip it, it's a half now. Okay? And in reverse, if the problem has a half, you're going to get 2 times wider. So if I scroll down here, here's a 2. It's inside the bars, so that's a wide issue. It's going to go half as wide. This is inside the bars. A 1/3, we think flip, that is 3 times as wide. I'm going to stroll over here, there's a 1/4, so that would go 4 times as wide. And those are some answers for down here on the bottom of the page on the 1 to 8. You can fill those in as we do. The last thing on the board I haven't addressed is number 13, which is negative signs. If they're involved in multiplying with variables, they'll make graphs flip. Yesterday's homework, we had no flipping, even though there were negatives, because they weren't multiplying variables. Negatives that multiply variables, that's where we're going to get some flipping. We can have things flip 2 ways. I can flip my paper this way, or I can flip my paper that way. It's 2 different things. If the negative is not in the parentheses or not inside bars, the graph will go upside down. If it is in the parentheses or bars, it's going to be reversed right and left, this way. Moral of the story, the parentheses or the bars sometimes trap things inside, okay, with the X. The X is always inside the parentheses or bars. If numbers join the X inside the parentheses or bars, that has to do with X's direction. X-axis is this way, so if we do a number with the X, it has to affect us this way. Adding moves right. Not adding moves left, sorry, opposite. Subtracting moves right. Multiplying stretches wider or shrinks it to be not as wide, or flips it this way, right, left. Anything in with the X is a right, left. Anything that's not is an up, down. So what I would do, well, let's go to the board for a minute. So looking for those flips. This one, the negative's not in the bars, so it's not to do with X. So that has to do with more Y kind of stuff, up, down kind of stuff. This kind of negative would flip me upside down. Then I'm going to use that little symbol to just mean I flipped it upside down, because it's easier to draw a flippy upside down than it is like write out a bunch of words. Step in here, negative that's multiplying. That's another flip it upside down. Walking through, negatives, negatives. Here's a negative, it's inside, so that's going to flip us sideways. Which if we pause and think for a minute about what would happen to a V if we flipped it sideways, the answer for today is literally nothing. Okay? But there will be days that that will matter, but not with V's. This would also flip us sideways, which for a V shape with the bars are V's. And again, that's going to be fairly useless. We don't have to worry about that with the absolute value columns. That did the bottom 1 to 8. From 9 to 16, if you were here in person, I would say take a minute, fill those in, and I'll get back with you. So I'll ask you to do that at home. Pause the video, take a minute, see if you can describe 2 times as tall, flipped upside down, 3 times as wide, half as wide, what's it doing? See if you can do those. Again, key ideas. Multiplying inside is wideness. Multiplying but not inside the parentheses is tallness. Negatives inside go sideways. Negatives not inside parentheses or bars go upside down. Take a minute, do that, pause me now, and now I'm back. So the list of 9 to 16 is going to go 2 times as tall. 10 is going to be half as tall. 11 would be flipped upside down. 12 is flipped upside down and it's 3 times as tall. 13's half as wide. 14's twice as tall. 15's flipped sideways. 16 is flipped sideways again, but also 3 times as wide. Likeliest mistakes are probably 14 that people didn't realize it's 2 times, wait, no. It should have been 2 times as wide back to 14. 14, 2 times as wide, sorry. And people on 16 not doing it to be 3 times as wide, because when they're in the parentheses, the wideness issues, there's like a reciprocal to it. 13, maybe people didn't have half as wide for that same reason. But the wideness ones, it's not the base number you started with, you have to flip it. So 13, half as wide, 14, twice as wide, 16 was 3 times as wide. That's the biggest issues on that. I am going to graph some graphs, but I'm going to graph them to match more like what the homework is. So 396 today is again still just V shapes with bars. So I'm not going to do any U-shape moves today. I'll save that for tomorrow. But the V shapes on this are 1 to 9. 1 to 9, the numbers are not multiplying inside. So that's a tallness question. 1 to 9, you're going to get a lot of V's that are getting taller. So let me tackle that first. So if I go to tackle this being 3 times as tall, I don't need a table, don't want to make a table. If you love the tables, make tables, but I don't know why you'd want to do that. So much quicker to avoid it. So we're going to go, vertex is still at the origin today. When you stretch things, it will not move the vertex. Every vertex on every graph from 1 to 9 will be at the origin. And then think about our normal pattern is over 1 up 1. If we're 3 times as tall, we're still over 1, but we're not going to be up 1 anymore. We got taller. So go times 3. Everything times 3 in this direction. Not up 1, up 3. And as yesterday, the left just mirrors the right. Over 2 is usually up 2, but not anymore. We're 3 times taller. So up 2 is gone. We need to go up 6. And we get a nice super tall V. If I go to do, I'll just do them in the order that they are. The negative thing is next. So what this did is it flipped this upside down. So again, vertex at the origin, because every single vertex will be at the origin today. No reason to move those. Over 1's not up 1, it's down 1. And mirror on the other side. Over 2 is not up 2, it's down 2. And we mirror that on the other side. And we make a V that's upside down. Not as tall as this one, because this one had a multiplier structure. This will be less tall, because it's half as tall. So again, vertex at the origin. Over 1 is only up a half. And we mirror that on the left. Over 2 is not up 2 anymore, it's only up 1, because it's half as tall. And you get a pretty flattened out kind of V that just isn't very tall. This I'll need to flip it again, so I have some space to do that. It's headed down, but when I do it, it needs to be 2 times taller than normal. So again, start at the origin for the vertex. Over 1 would go down 2's. Over 2, instead of being a 2 move, is now 4, because we're multiplying everything by 2 in the y direction. Good on those. This group up till now, every problem was affected this way. It was still 1, 2. Left, right, 1, 2. Every time, 1, 2. The heights changed by multiplying heights. When I step into wideness world, we have to switch our mentality. Everything in the height direction stays the same, and we're gonna change the overs. So our normal move is, again, vertex at the origin, over 1 up 1, over 2 up 2. My heights are still going to be 2s. Every graph that I'm going to graph from here until the end, I'm only going to need to worry about going like upper bound 2s. What's going to change is how wide these things go. So with this being half as wide, our maximum width is now not 2 squares anymore like it had been for every other problem. Every other problem went 2 squares left to right. This is only going to go 1 square left to right because it's half as wide. So my first move is going to only go over half a square to go up 1. And then instead of the final move being over 2 to go up 2, it's only over 1. It's half as wide. So we're up to the 2. The left continues to mirror the right, and on we go. This would go 3 times wider, so this is going to have a change for sure. I'll make a new axis because that'll be a little weird if I overlap that. Okay, if we're 3 times as wide, we're still only covering 2 in the height direction. No change to that. If we're 3 times wider though, I'm not doing my normal 2 marks. I have to do 6, because 2 times 3 is 6. So to do 3 times as wide, start at the origin. Initial move not over 1 anymore, it's over 3, because we're 3 times wider. To only go up the normal 1. And then over the full 6 instead of 2, 2 times 3 is 6, so over 6 to be 3 times wider than the norm. And then we're up the normal 2. Right is done, I just have to mirror that to the left. Sorry for any of you left-handed people, I keep discriminating against the left side of everything. I keep going right, then left. Maybe I'll do one left and right. But the 2 sides mirror each other, you don't want to discriminate against the left-handed. This one is going to accomplish, as we said, nothing in this case. If you have a V and you reverse it, you still have a V. So we're at the origin, we're over 1, up 1. And we mirror that on the left, still I'm discriminating, it's such a habit. Over 2, up 2, same graph as always. If I take the left and put it on the right, take the right, put it on the left, that accomplished nothing compared to our basic shape. This one, I can ignore the flipping sideways part, because as I just described, that's useless. I just need to make this 4 times as wide. So again, maximum heights on these wideness ones, it's still just 2s. But when we set up the x-axis, we have to go twice as wide as usual. Not 2 squares, but 8. And I'll go left this time first. 3, 4, 5, 6, 7, 8 is the full width. To the right, 1, 2, 3, 4, 5, 6, 7, 8 for the full width. So everything starts at the vertex, at the origin. So 4 times as wide is going to go over 4. And up the 1, that's normally the first dot we do, and then go to full width of 8 to go up 2. And this time I did the left, and now I'll mirror it on the right. 4s to go to 1, full 8 to go to 2s, and you get a V that's very, 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 very wide there. Just the chalk. So 4 times wider, 3 wide. That can now get you through half the homework. I'll hesitate here to reorganize myself, erase the board, and do another thing. But from 1 to 9 is like the left beginning part with the tallness. 19 to 21 is like the right for the wideness. You don't know how to do the middle sections till I clear this board and get another thing going. So I'll be back with you in a minute. So continuing the 9.3 lesson to do these other missing gaps with the board full of things. I have shifted now to the other paper. Okay, on this other paper, the first thing we need to do to be solid at is to be able to write down the descriptions of what these things are. So we'll do that in a moment. But the idea for these other graphs are, primarily our book will focus on the absolute value graphs, which are V's, which we've done so far. Starting tomorrow, we'll shift more toward the x squared equations, which are U's. But there are other equations with other graphs out there in the universe. So what they've done in the homework from 10 to 18 and 22 to 27 is they made up their own sort of weirdo graph. Okay, if you look at 396, from 1 to 9, they graphed you a basic V graph to look at to help you if you want to see it there. And then they have this other graph that has like a mountain and a valley right side by side. That has no particular equation that goes with it. So they just sort of made up a general name for it. Over the course of the year, sometimes we've seen Y's, sometimes we've seen f of x. And we had a lesson that we talked about how, more than once, that those two things are the same. Okay, f of x means y means f of x. What we've been doing the last couple days is I'm giving you absolute value specific equations to graph. What they're doing in the book is just making up sort of a general graph out of thin air with no equation that goes with it to back it up. No tables could be done. They've already graphed the graph, and what they want you to do is try to change that graph by stretching it today. So the first most important thing you will be able to do is figure out tallness, wideness, flipping, all those kind of things. And then we're going to have to adapt the graph that they made the way that I'll adapt the graph on the board. I made up my own sort of homemade graph on the board, and we'll adapt those in a minute. But what I would ask you to do first is scattered throughout the paper, 2 per graph, you'll see that there are these 8 formulas in this 8 orders. See if for a second you could take these and figure out what would change. Wide, tall, flip, what? And I'll do that in just a minute, so you could pause. And then we're back. So for this should have been 2 times taller. This one should go 2 times taller also. Multiplying not in parentheses is tallness, and we want to flip upside down. This would just be a flip upside down. The flip upside down caused when the negative is not inside the parentheses. This would be half as tall, and that'll be the 4 that I'll do to the left in a minute. The others, the numbers and the signs are inside the parentheses, meaning it's in trapped with the x. That's a wideness kind of thing. This is half as wide because the 2 has the flipping opposite effect. This will go sideways, which will matter. Okay, for V, sideways didn't matter. But these crazy graphs on this page, if you flip them this way, a mountain on the left would then become a mountain on the right. Or a valley on the right would become a valley on the left. We're flipping it this way. That will matter in a minute. This would be 2 times as wide. This is going sideways, and it's also half as wide. If you don't understand those, maybe rewind that and watch it again, or look at the paper we started the period with, fill in the blanks, and just try to make sense of these descriptions. The descriptions are the key to the whole operation. If you can't do the descriptions, you're at a dead end. We have to master that. If you have questions on that, email me and I'll try some. But if we go taking a walk back to the left, I'm going to break out the colors. Probably not. It's harder for you to see. I had on my notes different things on different colors, but for the first 2, the graph that's in the middle of the 3, you can see 3 graphs if you want to follow along with me on the graph page. Of the 3 graphs, the one that's in the middle is the original. So I graphed this on your graph paper. That's the middle one. You'll see a taller mountain, and you'll see a flipped thing that became a valley. The original graph that I'm basing everything from is the middle one. The whole board, I just replicated that graph 4 times. On your paper, I did it 4 times, just so it wouldn't get too crowded. Okay? So if we want to do first the 2 times as tall graph, we're going to look at these 6 dots. 1, 2, 3, 4, 5, 6. On your page, you should see 6 dots that are pretty heavily dotted up. Okay? If we make things taller for these first 4, we're only affecting things this way. None of the x-axis numbers changed. I'm only going to go this way. And I catch a break on 3 of these 6. Okay? This is not moving. This is not moving. And this is not moving. Those are anchored. You can see there's 3 graphs that all go through those same 3 dots. We're not changing those, because if we make things 3 times taller and they're at 0, 3 times 0 is 0. So far my my channel here has made $0. Tomorrow I can make 3 times as much. I'm still making $0, right? So, but the other numbers, we're going to have to go times 2. So this is presently a mountaintop at 3. Make it twice as tall. It's now a mountaintop up at 6. This is a touch point on the y-axis at 2. Make that 2 times taller. Now your touch is at 4. Play connect the dots, and we have the beginning of our mountain. We said that was going to stay anchored, so I want to click that. Then here's our valley. Our valley was at a depth of 2. Make it twice as deep. And we line up now with 4. We had these anchors. We have this. So our valley just got twice as tall. Imagine this is our original graph, and I just stretched it like it's a spring. Everything got taller. Second picture, we're going to go twice as tall as well. So we already did the math on the twice as tall. The only additional change I have to make is to flip this thing. So I just need to take my twice as tall numbers that I've already accomplished, and instead of going up, now stay in a line, just go down. Instead of being 6 on the upside, it's -6 on the downside. This is going to be, instead of up 4, down 4. This valley, instead of down 4, is going to go up 4. And then we just need to play connect the dots using our 3 that we're never going to move, and then the other 3 we had to wiggle around a little bit. So valley, this mountain just became a valley, and this valley just became a mountain. That's the kind of thing you're trying to do, but on the home, or not using this graph. They did you a new graph. They have a red graph with mountain, valley, and slightly different squats, but the same idea. The next 2, we're doing the same kind of stuff. Again, it's tallness. So again, we're not changing anything about the x directions. This is not going anywhere. This is not going anywhere. This is not going anywhere. We'll repeat those every time. We just have to change the other 3 dots where they're located. The first one I'm going to do is the negative to flip it upside down. So the mountain that's 3 high is going to become a valley that's 3 low. Touching that's up 2 above will now be 2 below. And I might as well make that valley while I'm thinking about it. This that was down 2 is now up 2, so the valley became a mountain. All we did is flip. If we go half as tall, again, leave these untouched. Just take every height and make it half as high. And you could go in any order you want to. I'll work from right to left this time. So the mountaintop lined with 2, it just became half of a mountain. It lines up with 1. And that is half as tall as we started. This was up 2. Now the touch would only be up 1, half as tall. We have a decimal or fraction here, sorry, they happen. Because 3, to cut 3 in half is a little awkward, it's 1 1/2. So staying in line with everything else we were doing with these other dots, just make it, instead of up 3, come halfway down to 1 1/2. And here is our half as tall kind of mountain, and we're halfway through. If you don't get that, rewatch it. 10 through 18 are based on that idea. When you're done, settled in, 22 to 27 is a different game. We have to, again, switch our perspective. We've switched from tallness stuff with the numbers not in the parentheses. We've switched to wideness stuff with numbers in the parentheses. So for wideness, these 3 anchors that we've had set in stone are now going to move. And this is going to be a little more work because I have 3 now that are in motion. The 3 x-axis points have been set, now they're not. The 1 y-axis point hasn't been set, but now it is. So at least we have 1 that's preset, okay? But anything wideness, if I'm going to stretch this wider, this 1 is staying, everybody else has got to move. So if I go half as wide, all of these x-axis numbers, we're going to line up and change in different ways. The heights aren't changing this time. Okay, so I'm not going to go any higher than this. I'm not going any lower than this. No changes there. But we're going to change things this way. So if I go half as wide, the left 4 is this position. I have to go half the width back to 2. The mountaintop this way is 2 squares, so I need to go half as much. I only want that mountaintop to be 1 square away from the y-axis. I won't connect anything yet. This is right 4, so I need to go half of that and settle at 2. This end line was 6, so the end line, half of that, is 3. So that's now the finish line. Instead of 6, shrunk to 3. 2, 3, 4, 5. This lined up with 5 to be the valley. We need that valley to come back here an awkward fraction or decimal. Okay, 5, half of that is 2.5. So I have to crush this halfway back to line up with 2.5. It'd still be the same height of a thing. It's still only 2 underground. So I need to connect from here to here, through our anchor, one anchored point, to there, valley, up. Okay. The original thing was here, and then crush. It's half as wide. Second thing we're doing with those is a flip. So if I do a flip, I think I am going to go color just to make this a little bit better. So flipping sideways, so everything on the left is going to head toward the right, and everything on the right will head toward the left. So my original thing had 4 to the left on the x-axis. Now that's 4 to the right. The mountaintop was left 2, so the mountaintop is now right 2. This is anchored. We're not going anywhere with that. This was an original point, which was right 4, so I'm going to go left 4. The finish was originally right 6, so I'm left 6. And this valley was in the middle of those two at 5, so I need to bring the valley over here to a -5. And there's our valley, just got flipped. Here's our mountain, just got flipped. The whole thing flipped. Okay, so the orange and the original white are reversals of each other. For this one, I'm going twice as wide. So you can already tell by the numbers. Numbers got real big all of a sudden. This was finishing at 6. I had to go all the way to 12. This one finished originally at -4 in my original picture. I'm back to -8. I took everything and I'm twice as wide all over the place with everything. So twice as wide, finish line of 6 is out to 12. Touch point of 4 is now at 8. Touch point of -4 is out to -8. And you can do these in any order you want to do them. I just did all the x-axis. 3 x-axis numbers, they're all moved. Mountaintop used to line up with 3. Now the mountaintop, I miscounted on my original thing. Mountaintop used to line up with 3. Now it lines up at 6. This is anchored. And my last thing I have to do is my valley. Or is it 5? So I need to take the 5 out to 10, but stay the same height that it was. And what we just did there, if we imagine taking the white and stretching it twice as wide, we're now out there in the orange world. The last one we have, we're trying to go half as wide. and we're trying to flip it sideways. So, what do you think? Another white or another orange?
Probably another white.
Another white. Okay. So if we go half as wide and flip it, everything left goes right, everything right goes left. So left 4 becomes right 2. The mountaintop that lined up with 3 now lines up with 1.5. And this is anchored. So this thing just is going to turn into this thing. We have a little bit of an M-ish kind of thing. This became that, but this half is half as wide. Then this was an original point, right 4 is going to go left 2. So we just continue that going. Finish line was right 6, so we go left 3. And then the valley is halfway in between those, lined up with 5. The valley now has to line up with 2.5. And what we did is we spun it and made it half as wide. And that's what you're trying to do from 22 to 27. Best wishes. Send me questions if you have any. I'm going to go color just to make this a little bit better.
Pick a brighter color.
What do you think? Yellow?
Maybe.
Orange?
We'll try it.
Try yellow, see how it looks from the back. Is that going to be able to be differentiated from where you are?
It looks kind of white, like it's...
Can you see orange better?
Yes.
Green?
I can see green, yeah.
What's the better one?
I think
Light green?
light green looks really white.
Alright. Probably the orange then?
Yeah, go orange.
Alright.
It looks like yellowish from here, but you can still tell it's different.
I have a purple.
What does that one look like? Go orange, I think.